Guys, welcome back to the Wake Up Call 101 channel. So today we're determining the rate law of this reaction. So remember when I told you in my previous video that the reaction orders, you determine the reaction orders experimentally. So this is one of the examples I took from the book actually. So we're using initial concentrations to find the rate law equation, using the initial concentrations of the reactants and also the initial rate of the reaction. So we have three different experiments. Okay, so the form in which you write your rate law, so by now you know, is rate is equals to K, our rate constant, times the concentration of A, which is our reactant, to the exponent M, our reaction order, times the concentration of B to the exponent M. So to find the reaction orders, you need to, looking at this table here, from experiment 1 to experiment 2, the initial concentration of A did not change, but the initial concentration of B did change from 0.100 molar to 0.200, which did not affect the initial rate of the reaction at experiment 1 and 2, because it stayed the same. So I'm assuming that since the initial concentration of B does not affect the initial rate of reaction, I'm assuming that this reaction here is zero order in the concentration of B. So looking at experiment number 1 and 3, the concentration of A did change from 0.100 to 0.200, while the concentration of B did not change, but the initial rate of the reaction did change from 4.0 times 10 to the power minus 4 to 16.0 times 10 to the power minus 4. So you need to find the reaction orders here. So looking at experiments 1 and 2, A did not change, so we're not finding M, we are finding N, since in this case the initial concentration of B is the only one that changed from 0.100 to 0.200 molar. So to find out these reaction orders, we need to find the ratio of the rates at these experiments. Experiment 2 over the rate at experiment 1, which is equals to 4.0 times 10 to the power minus 4 over 4.0 times 10 to the power minus 4, which is equals to 1. So you're going to use this ratio here, rate equals over rate 1 equals to 1. You're going to use this ratio to find the exponent of the exponent M. So the initial concentration of B at experiment 2 is 0.200 to the exponent N, and at experiment 1 it is 0.100 to the exponent N, which is equal to 2 to the power N. So this is like this. Now we know that this one can mean that it is the same as 2 to the exponent 0, to make it easier to find the value of N. So our N here is equals to 0. So here's the reaction. This reaction is zero order in B. So let me pause the video so I can find the reaction order M for A. So now we need to find the reaction order N. You're gonna use the same format. So we first find the ratio, because the concentration of A affected the initial rate of reaction at experiment 1, from experiment 1 to experiment 3, because the concentration, we doubled the concentration. So it's gonna be rate 3 over rate 1 equals to, so we're finding the ratio here. So it's gonna be the initial rate at experiment number 3 is 16.0 times 10 to the power minus 4 over the initial rate at experiment 1, which is 4.0 times 10 to the power minus 4, which is equals to 4. Yeah. So rate 3 over rate 1. Now we're using the concentrations of B, the initial concentrations of B for experiment 3 and experiment 1. So for experiment 3, it was 0.200 to the exponent m over experiment 100 to the exponent m, which is equals to 2 to the exponent m, and then we're left with this. To find the value of m, this is the same as 2 to the power 2, which is equal to 2m, and our m is equal to 2. So this reaction is second order in A. So when you add the reaction orders m and n, it will give you 2. So the overall reaction order for this reaction here is second order this reaction here is a second order reaction. So our rate law will then be, because this will be 0 and this will be 2, so this will just be 1. Okay, anything raised to the power 0 is 1. So our rate law for this equation is rate is equals to K times concentration of A squared. Yeah, it's going to be like this. So it is a second order reaction. So when you're asked to find the value of K, you're going to use this equation here, this rate law equation here, and you know by now that if it's a second order reaction, the units for K will be per molal per second, which is per molal per second. If it was the first order, it was going to be per second. It was zero. If it was a zero order reaction, it was going to be molal per second. So thank you guys for watching. Please tune into my next videos. They are going to be as helpful as these ones, the previous ones. Thank you very much for tuning in, and thank you for the subscriptions, for the views, the likes. Thank you very much for the